this class 270, 360. It could be a negative measure to work with, which seems odd, but that's what's happening here. But tonight, just to give you a brief introduction, you're accustomed to this. I'd be accustomed to this. That's an angle, professor. And then back when you first saw this, that teacher was very patient, I'm sure, who was teaching that course, I hope so. And they probably passed out an instrument and showed you how to use it to place on that angle and see and find its measure. Does anyone recall what that instrument was known as? Protractor. They passed out protractors, and more than likely they came by your desk and said, "You know how to line this up?" "Oh, yes, I know how to line this up." You lined it up, and you say, "Oh my goodness." All I do is, if you give me that protractor, teacher, all I do is just line up in the proper way, and I'll say that angle right there is a measure of 30 degrees. That's all they're saying in section 5.1. I can do that across the street with this. Now, though, for us, that's what the basis of all this is, though. But for us, guys, we're going to do this. Let me think of a good way to do this and not mess up. I want to do this. I'm going to capture this in a circle. I'm going to have this angle located in a circle. Now my circle's not drawn perfectly. I did want this to be like the center right here at this point. Now, here's the conversation taking place here. For us, for higher math, I'm not going to pass out protractors. Don't you go to a math 7 class and ask them, "Where's my protractor?" We're not going to do protractors. We're going to come up with another way to get the measure of this angle and not use a protractor, not use degrees, period. Another way to express to someone the size of this angle, the measure of this angle, would be, if possible, tell them how much of the circle, this arc, tell me its length. And where the length of that arc is, cut out by that circle, by that angle on that circle. Whatever the length of that arc is, that's what we'll accept in these higher math courses as the measure of that angle. So rather than saying 30 degrees, shortly we'll say something else. And that we're actually saying it it's just in a different way, different manner. What's the length of that arc that 30-degree angle cuts out of the circle? Now I've got to use a little common sense tonight to lead you into it. Guys, the total measure in degrees of that full circle is 360. There's 360 degrees in a circle. I don't have all 360 right here in this angle. I have only 30. Something else that may come out of this, which I'll need for the length of that arc. The length of the entire circle is known as circumference. Does anyone remember the circumference formula to find the circumference, the length of a circle? Yes? Oh, I think you're trying to give me an area.
Oh.
David?
Isn't just diameter?
No, something else easier. So I need circumference. How do you find the length of the entire circle, or a portion of it for us here shortly? There was a circumference formula that gave you the length of the circle. Something easier. Samantha. 2 pi r. 2 pi times the radius. 2 pi times the radius of the circle. Notice I have not given you a definite number for the radius. I know where the radius is. You know where the radius is. It's right here. From the center, and also here. From the center out to the circle. That's radius. But I have not given you a particular number to plug in to find the circumference. Guess what number we love to work with for the radius? 1. We want 1, the easiest number to work with. We want that radius to be a length of 1. If I do, if I set it equal to 1, right here, then we're into a circle known as, and I'm sure some of us have worked with it before, the circle now is known as a unit circle. It has a radius of 1 unit. And they call it a unit circle. 1 unit radius. Now, with that set up, the circle, I got a circumference of 2 pi here. Now, with the little bit of time I have here, I want to somehow rewrite 30 degrees from middle school, rewrite it for one of our advanced classes here. And it's going to be a different name given to the measure. It's not going to be called degrees from now on. I want to come up with another way to indicate to someone, I'm still talking about 30 degrees, but I'm not going to say 30 degrees protractor business. I'm not going to do that. I want the length of this arc first, and it's a unit circle. Does anyone have an idea how on earth could you find the length of that cut out arc on that unit circle? Here we go. Yes.
It's pi over 6.
Okay, now let's go through the details first though. Okay, the circumference of the full circle is 2 pi.
Yeah.
Okay, guys, that is everything. That's the full circle. Do I have the full circle here? No. So if you need a little rationale, I have 30 degrees, and you guys already told me what? There's 360 degrees in a full circle. So you say, wait, Professor, if you really want to find out what's going on here, you have 30 degrees compared to 360, because 360 is in the full circle.
Yeah.
And we'll go ahead and reduce that down, guys, to 1/12. So I have 1/12 of the full circumference. I don't have the full circumference up here. I just have this much of it. So I have 1/12 of this. So on the side here, I have 1/12 of the 2 pi, not the entire 2 pi. And unfortunately, we ended up with 2 pi over 12. And the student told me right quickly, Professor, my goodness, it's pi over 6. Now, go on to Math 7, Math 8, move yourself on to USC, Berkeley, wherever. My UCLA student, she's stopping by on Monday to talk to you guys. We now will recognize pi over 6. In your mind, you gotta think, oh my goodness, he's talking about 30 degrees. I am. Except it's a different measure, it's pi over 6. Now I'm giving the name to it, it's not called degrees now. So we're actually talking about the same angle. But it's just in a different way to talk about it. David, go for it. Oh, yeah, let me put word down. Yeah.
Is that point C in the middle of the circle?
Yeah, I want that center to be at 0, 0.
Oh, is it? Yeah.
No, I don't have it. That's not a perfect circle there. Yeah, center is right at 0, 0. Let me do that real quick. And I want the units, the radius to be a 1. Easiest number to work with for a radius. I don't want radius 2, radius 5, radius 10, radius 12. I don't want that. These are 2 big circles to deal with. Radius of 1. Convenient. That's why we call it 1 unit circle. Now that said, here we go. They do give a name to when they change the measure. It's not 5 or 6 degrees. I don't use the degree mark. They call this, I'll use this up here. They call this radian measure. And when I hear the word radian, my goodness, I hear the word radius. So it has something to do with the unit circle. So that's the name given to it. So now it's pi over 6 radians. That's the measure. That's equivalent to 30 degrees. We're talking about the same angle. Okay? Now, we got time. Now suppose I do this. Go back to my circle. And I say, this time let's consider this. Let me go back to the blue. And my circle's off a little bit here. And I know that I'm indicating right there a right angle. I'm right angle. Measure 90 degrees. Now if you do what I've been doing tonight, you'll say, wait, Professor, another way to do that, for someone to recognize that you are talking about 90 degrees, is go back to the beginning of your circle, shade again, this is what's being cut out, and I go to 90 degrees, yes, All that's being cut out to form 90 degrees. So I need, in this case, how much of the circle? Give me a ratio. 1/4 of the full circle. So you say, wait now. So you're telling me, Professor, 90 degrees can be expressed as 1/4 of the full circle, which is 2 pi. Which is like 2 pi over 4, which reduces down to pi over 2 radians. Now, for those of us who have never seen this before, it's so strange to think, you walk up to someone and say, I'm thinking about an angle of size pi over 2. Pi over 2 is like 3.14 divided by 2. It's a number, 3.14 divided by 2. Then in your mind, you're going to think, oh, he's talking about 90 degrees. Then I'm seeing in my mind a picture of it. It's a 90-degree angle, a right angle. This is a different measure. It's called radian measure. Guys, you see the connection there between the circumference of the circle and the circle itself and all that business to convert from one to the other. Now, when it flows down, plenty of time for this. I'm not going to sketch 35. 35 degrees, I'd like to know what it looks like in this new measure called radian. And they want to tell me real quickly just how you might set it up, think about it, and we'll do it.
Same thing you have already, just put 35 to 360.
Hang on now. So you're saying compare 35 to 360. Is that true? 360 degrees in the full circle, right? And then, David, you have more. Times what?
You said that equal to 2 pi.
Well, it's how much circumference do we have here? 2 pi? Is it 2 pi, guys? I think it was, wasn't it? For the full circle? 2 pi r, and radius is 1. So if you simplify that and do the best you can here, I can do a little canceling. This is 180. Not as nice as the others I had here. 35 over 180, I think that reduces down also maybe by 5. Was it a 7 over, help me out, 36? I think. Is that true? I just reduced it down. Now, before I pass out the quiz, that's the last thing we do. If I walk up to you on campus and say, I'm thinking about an angle of size 7 pi over 36, you quit and say, Professor, glad to see you. You're thinking about an angle of size 35 degrees. That's exactly what I'd be thinking of. An angle of size 35 degrees. If we're across the street, then we come back over to campus, it's going to be represented as 7 pi over 36. Is that rationale making sense? Lord, I hope so. I'm looking at myself, I hope it is. Guys, is it?
Yep.
I did quick, I reduced it down. Was that 180 here? Was this 180? Or did I reduce it down to 30? It was 36, wasn't it?
Yeah.
It was a 36? I reduced it
Yeah.
down. Woo! Jeez. Now, take a breath. We're ready. We're a little away. And you know me, if we stay late, we stay late. If it takes that time, I don't care. We'll be here. What's that? I'm gonna find some. Kyle, would you have some scratch paper if we should need it? I think we ran out here with Mr. Park on scratch paper.
I can check.
You think maybe downstairs they have some?
I mean, I can check. I'm not sure, but.
Well, let's see if he has some first. I don't want to kick off. Now, Kyle, is it okay to use that? I don't want to use all your paper. You sure? Okay, guys. Take your time on this. Don't rush through it. We're here till 8 o'clock. We're good. short, but take some time.
So what you get for the last piece? Yeah,
I have these scored.
kindergarten.